the very famous electronic device that you can design using semiconductors is transistors. Transistor is a 3-terminal 2-junction device. 2-junction device. So, here you can have two p-n junctions, NP and PN. It has got 3 terminals, emitter, base and collector. As we all know, emitter is highly doped and it is having moderate surface area. Base is lightly doped and it is very thin in order to control the flow of charges, hence current through that gets through to the collector. And collector has got moderate doping but large surface area. So, NPN transistor, this is a direction of the current flow where electrons go out from emitter towards collector, hence the current direction is taken opposite to the electron flow. Whereas the PNP transistor, you have electrons going through to collector, electrons going rather it is going towards collector and the current is opposite to the conventional flow. So, transistor is operated with the one input loop and output loop. Usually the output loop is a collector. So, the collector emitter loop is a output loop which is reverse biased and the input loop is always forward biased. This is base to emitter voltage, this is collector to emitter voltage. Now, if you observe here, input loop has got emitter in common, the output loop has got emitter in common. Such a mode is called CE mode of operation of a transistor. That is nothing but common emitter mode. Common emitter mode. Here current amplification takes place. So, the current amplification, input current is controlled, the output current controlled by input current, that is base current, output current is a collector current. However, by conservation of charges, emitter current is shared, some of the current go through to the base. So, it is given by the formula IE is equal to IB plus IC. IE is equal to IB plus IC. So, these are some of the formulas that we associate. However, it will also give the voltage gain. So, the input voltage is the input current IB will be input voltage divided by input resistance. Hence, input voltage will be IB into RI or R input. Similarly, output voltage is IC into RC. So, the voltage gain AV is output voltage by input voltage. This when we write output voltage IC into RC divided by IB into RI. So, it is beta RC by RI is the formula for the voltage amplification. So, since you have the junctions in transistors and they are the input side usually comes to be emitter and base in CE configuration. They are always connected in forward biased. So, the input IV characteristics that you get by maintaining a constant potential difference VBB is that when the voltage across the collector and emitter changes, it gives you the typical PN junction forward bias IV characteristics, which will be taken as a input characteristics even for transistors. However, the output characteristics must be taken across the collector and emitter to which there is VCC connected, which is in reverse bias. So, if I take this as a NPN transistor, then this is a reverse bias. So, now if I keep the base current constant, say IB1, and if I keep changing the voltage across emitter to collector, this voltage if I keep varying it, this is how the collector current varies, and this region is a saturation region, and this constant current will be utilized in operating the devices. So, this is our output characteristics of a transistor when connected in any mode, but easier to explain using CE mode, that is common emitter mode. Now, if we think of common base mode, the current amplification factor is alpha, where base is common to both input and output. So, current amplification factor alpha is given by IC by IE, because base is common. Base is common. So, always the collector current is less than the emitter current, hence alpha is less than 1, beta will always be greater than 1 in CE mode. This is a comparison you got to remember. The relation between alpha and beta can be easily derived. So, the principle of conservation of charges if we apply, IE is equal to IC plus IB, you divide this by IC throughout the equation, then it will be 1 plus IB by IC. So, this is 1 by alpha. In CB mode, since base is common to both input and output, the output current is collector current, input current becomes a emitter current. So, it is 1 by alpha is equal to 1 plus 1 by beta, 1 by beta. So, taking the common denominator, it will be beta plus 1 divided by beta. So, alpha is beta by beta plus 1 is one relation that is between the current amplification factor in common base mode of the transistor and which relates to beta, which is nothing but current amplification factor in common emitter mode of the transistor. Also, this formula can be further written as, suppose if I consider this fraction of the series of equations, then it is 1 by alpha is equal to 1 plus 1 by beta, 1 by alpha minus 1 is 1 by beta. So, if I take alpha as a common denominator, then it is 1 minus alpha is equal to 1 by beta. So, beta is alpha by 1 minus alpha. Hence, beta is always greater than 1, alpha is always lesser than 1. These are the things to be remembered.